So Ian Smith will go first. Finished his internship with the city of Boston earlier this year, and Ian's talk is titled Evaluating the Cooling Impact of Vegetation in Boston, Massachusetts. Ian.
Great, thank you, Evan. So my name is Ian. I'm a PhD student in the Earth and Environment Department, and as Evan said, this past fall, I completed my urban program internship with the city of Boston to develop and implement a framework evaluating the cooling impact of vegetation in Boston, using the proposed reconstruction of Melnie Cass Boulevard as a pilot study. So cities tend to experience warmer temperatures than surrounding rural areas, making them especially susceptible to projected increases in the frequency and severity of droughts and heat waves due to climate change. Trees have been identified as a key nature-based solution towards improved heat resiliency in cities, as they provide cooling through two primary mechanisms. Trees provide shade by preventing direct sunlight from reaching the surface. However, trees also cool the air around them through their activity. While trees are taking up atmospheric carbon dioxide for photosynthesis, they're simultaneously releasing water vapor from their leaves in the transpiration process, which consumes a tremendous amount of energy, resulting in a cooling effect, which we refer to as the latent heat flux. In this project, I aim to work with the city to estimate the amount of heat mitigation provided by the current tree population along Melnie Cass Boulevard and what the impact of a proposed reconstruction project might be on the supply of cooling. So here on the left, we see the current and proposed tree population along Melnie Cass Boulevard. Tree size is designated by the size of the circle, and the treatment of each tree is designated by the color of the circle, where blue trees were to remain unchanged, red trees were to be removed, and green trees represent newly planted saplings. On the right, we see a map of the daytime surface temperature along the boulevard derived from a satellite image taken this past August, where the black boxes represent our study area. We can see that the dense population of trees on the western half of the boulevard is currently providing a strong cooling effect. I work to combine models of city size and species-specific growth and mortality rates with a spatially explicit urban latent heat flux model to estimate the potential change in vegetation cooling benefits immediately following the completion of this proposed reconstruction. Next slide, please. Here we see the results for year one following the reconstruction project, where pixels, or these 30-meter by 30-meter boxes that are more red in color, represent pixels that might experience a warming effect, and the green and blue pixels represent pixels experiencing more cooling. The inset graph follows the same color scheme and shows the number of pixels experiencing a given change in cooling. The broad take-home message is that while much of the boulevard would remain unaffected by the project, some areas will experience a large loss of cooling. The spatially explicit modeling framework, however, can identify those areas where small-scale design changes may also be able to improve the proposed project. In addition to considering the changes to the supply of cooling, I also generated a similar map of cooling demand based on the heat vulnerability of residents and commuters along the boulevard to further target areas where design changes might be prioritized. And this full analysis can be found on the BU Urban website. My favorite part of this internship was the opportunity to apply my research to a pressing real-world problem. And while the Melnie Cass project has been put on hold, I'm continuing to work with the city to consider the impact of various landscape development strategies on improving heat resiliency across Boston. Thank you.